Welcome to our channel, where today we will show you how to craft the most powerful digital antenna for tuning high-definition channels on your television. With easily obtainable materials, we will guide you step by step in creating a homemade digital antenna that will maximize signal quality and allow you to enjoy an exceptional HD viewing experience. Don't miss out on this practical tutorial and discover how to enhance your TV channel reception with a powerful and efficient antenna. Step 1. Material acquisition. Let's start by searching for aluminum tubes with a diameter of 10 mm. Ensure you have sufficient length for the following cuts: 2 tubes of 12.5 cm, one of 20 cm, and another of 27 cm. Step 2. Dipole preparation. Mark 2 tubes each with a length of 12.5 cm. Step 3. Director creation. Mark another tube with a length of 20 cm. With the appropriate tools, make the cut following the mark. This tube will be the antenna's director. Step 4. Reflector construction. Find a tube with a length of 27 cm. Once again, carefully make the cut at the mark. This tube will act as the antenna's reflector. Step 1. Acquisition of the insulating plate and base preparation. Before starting, make sure you have a suitable insulating plate. Now, for the base that will support the active elements, follow these steps. Step 2. Measurement and marking of the base. Take the insulating plate and carefully measure 0.4 cm in length, 3.0 cm in width, and 6.0 cm in height. Use a ruler and a pencil to mark the dimensions on the insulating plate. Step 3. Base cutting. With the marked measurements, use appropriate cutting tools to cut the insulating plate along the drawn lines. Ensure you obtain a precise and clean base. Step 1. Acquisition of aluminum profile and boom preparation. Let's begin by ensuring we have an aluminum profile with the appropriate dimensions: 1 to 2.5 cm in width and 30 cm in length. Step 2. Marking dimensions on the aluminum profile. On one side of the profile, measure and mark the following points: 7 cm from one end, then an additional 15 cm, and finally 6 cm from that point. Use a ruler and a marker to ensure precise lines on the aluminum profile. Identification of the reflector and director centers. Repeat the process to identify the center of the reflector and the director. Measure diagonally on both pieces and mark the midpoint. Secure the reflector and the director at their respective centers, using the previously identified marks on the base. Creation of the plastic base. Locate the center of the plastic base by measuring diagonally from one corner to the opposite and marking the midpoint. This will be the center of the base. Assembly on the base. Place the plastic base in the center of the aluminum profile, ensuring it aligns with the central mark you created. Step 1. Acquisition of the plastic rod. For fixing the dipoles, acquire a plastic rod with a diameter of 3/8. This will be crucial for securing the dipoles effectively. Step 2. Marking and preparation of the dipoles. Insert the plastic rod into both dipoles, clearly marking the center of the rod. Use a ruler to separate lines on the rod, leaving a space of 1 cm between them. These lines will indicate the exact position of the center and facilitate installation. Step 2. Marking and preparation of the dipoles. Insert the plastic rod into both dipoles, clearly marking the center of the rod. Use a ruler to separate lines on the rod, leaving a space of 1 cm between them. These lines will indicate the exact position of the center and facilitate installation. Step 3. Assembly on the plastic base. With the plastic rod prepared and the dipoles marked, place the plastic base on the antenna structure. Align the dipoles in the desired position on the base, ensuring that the lines marked on the rod are aligned with the previously identified central points on the base. Step 4. Fixing the dipoles. Use clamps or your preferred method of fastening to secure the dipoles in place on the plastic base. Ensure that the dipoles are securely attached and aligned according to the marks made on the plastic rod. Step 5. Verification and adjustments. Verify that the dipoles are correctly installed and aligned. Make adjustments if necessary to ensure that the dipoles are in position and ready to receive signals optimally. With these steps, you have prepared and secured the dipoles precisely on the plastic base, using the plastic rod as a supporting element. This approach will ensure a stable installation and enhance the efficiency of the antenna in receiving HD signals. Continue with the enthusiasm of your project. Step 1. Preparation of coaxial cable and connector. Cut 16 centimeters of coaxial cable and attach a connector to the end of the cable. Ensure a secure connection to guarantee optimal signal transmission. Step 2. Connection of coaxial cable to dipole. Strip the tip of the coaxial cable to expose the inner core and outer insulation. Connect the inner core to the dipole, ensuring a firm connection. Also, connect the outer insulation to the dipole for a complete connection. Step 3. Drilling the boom for coaxial cable. Drill an 8 mm hole in the boom, near the dipole. This hole will allow the coaxial cable to pass through the boom. Step 4. Routing coaxial cable and fastening to boom. Thread the coaxial cable through the newly drilled hole in the boom. Secure the coaxial cable to the boom using clamps or other fastening methods to ensure a stable installation.
All I want
Step 5. Drilling for mounting point on wall base. At the end of the boom, near the reflector, drill a 6 mm hole. This hole will serve as the mounting point on the wall base. Conclusion. Congratulations on completing the construction of our powerful HD channel antenna. We hope this tutorial has been helpful and you can now enjoy improved reception on your televisions. Throughout the process, we covered every detail, from preparing the active elements to connecting the coaxial cable, and finally, installing it on the wall base. Now, the next step is to demonstrate the effectiveness of the antenna. Live demonstration. We have mounted the antenna on our wall base and connected it to the television. Continuing with the action, we will perform a channel scan to validate the quality of the reception. The antenna, with a gain of 6.4 dBi for digital UHF frequency, demonstrates its ability to accurately capture signals with clarity. Versatility for all TVs. It's important to note that this antenna can be used on both older and modern televisions, providing a universal solution to enhance the viewing experience. Recommendations and upcoming demonstrations. While we have installed the antenna indoors, we recommend considering outdoor placement for optimal optimal results. In the coming days, we will conduct another outdoor demonstration to show how to further maximize signal reception. Finally, we appreciate your participation and enthusiasm in this project. If you wish to stay informed about future tutorials and demonstrations, we invite you to subscribe to the RF Antenna Design channel. We are excited to continue sharing knowledge and experiences related to antenna design and signal reception improvement. Thank you for being part of our community, and until the next demonstration.